Thank you so much for joining the webinar today on Connected Construction Data Alliance. My name is Allie Kelly. I'm Executive Director of the RAY, and the RAY is so proud to host the webinar today with several of our colleagues from leading state DOTs in connected construction. I'm just going to get us opened with a couple of reminders of how the webinar is going to operate today and the content that we're going to cover. First of all, a note that the webinar is being recorded and the recording will be available in the coming day or 2 days after the webinar. Also, we're going to hold questions and answers to the end of the hour and the end of the webinar, but we encourage you to use the chat function of Zoom webinar in order to record your questions as they come to you, and we might be able to respond to some of your questions or comments as we're working through today's webinar. So as I said, I'm Allie, I'm with the RAY, and we're excited to be a part of a state DOT team introducing the Connected Construction Data Alliance and the Transportation Pooled Fund that is launching the Alliance. We're also going to be discussing how Iowa, Delaware, and Maryland DOTs are unleashing work zone data and leveraging connected construction technologies and applications, even exploring technologies and applications like digital inspection that are near future and that will lead to far future innovations around inspection. All of this to improve safety and to access operational efficiencies. As a part of this webinar, we're also going to talk about existing funding streams that can be leveraged to help leapfrog your state programs and accelerate your progress towards some of these applications, including SPNR, CMAQ, Everyday Counts, and the new USDOT Connected Corridors program. Just a little bit of background on the RAY for those of you who aren't aware of our work. I'm located in Atlanta, Georgia, where the RAY is headquartered, but we're a national nonprofit organization, have been in operation for over 10 years. And our mission is to reimagine transportation and transportation infrastructure to be safer, cleaner, and more productive. Our first DOT partners in our home state at Georgia DOT, along with the RAY and GDOT, we've developed a test bed on Interstate 85, which is now known as the RAY Highway. Safety is core to the mission of the RAY, and at least half of the infrastructure projects that we have developed with GDOT on the RAY Highway are focused on improving and enhancing transportation safety. But we do work nationally across all levels of government to facilitate innovation in transportation and infrastructure projects. And some of our partners include at the federal level, USDOT and USDOE. We work with more than half of the country's state DOTs and a handful of tollways, Class 1 railroad systems, and CVG Airport, our inaugural airport partner. So now I'd like to go through and introduce our speakers in the order that they will be speaking. First, we will hear from Cassidy Blowers, who is the statewide construction resource engineer at Delaware DOT. Cassidy's got 18 years of experience in highway construction, and she has become a leader in the implementation of equipment telematics to deliver real-time worker presence alerts and to enhance safety in work zones as a part of the Federal Highways ADCMS initiative. Second, we'll hear from Jimmy Hovatter, E-Construction Business Manager for Maryland DOT's State Highways Administration. Jimmy has 22 years of experience as a project engineer and inspector, and he administers the Maryland DOT e-construction systems, including the integration of new technologies. Third, we will hear from Cedric Wilson, who is the e-construction program administrator for Iowa DOT. Cedric has 33 years of experience in highway and bridge construction and is a national expert in digital delivery and e-ticketing. And our last speaker is Roy Sturgill. Dr. Sturgill is the Associate Professor of Civil, Construction, and Environmental Engineering at Iowa State University. He has a former career in engineering with the Kentucky Transportation Cabinet, and he also chairs the USTRB's committees on utilities and right-of-way. We'll be hearing from our speakers with the ability to ask questions and post comments in the chat bar for the next 45 minutes. And so I would like to ask Cassidy if she will share her screen, and we will start by hearing about the experience in Delaware with Delaware DOT.
All right. Switch over to the share. And I hope everyone's seeing my screen now. All right, I'm seeing nods, so we're going to go. All right, so I get the lovely task of explaining why we're going with a pooled fund and, kind of how we got to this point. So the why of what we need this pooled fund for. So pooled funds at their core are about partnership and collaboration. And not just, amongst other state DOTs, but also amongst industry partners, experts, academia, FHWA. That is the whole point of a pooled fund. That's why we're looking to do this pooled fund. And it's really an expansion of our existing ADCMS program. Delaware was one of the first states to be awarded ADCMS, and our ADCMS grant was unique in that it was a multiple state application. So it wasn't just Delaware, it was a total of 4 states in our cohort. And obviously, when you're involving 4 different states, it's not just one state's contractors, it's multiple states' contractors. And we end up involving multiple equipment manufacturers in our project. So partnership was at the core of what we did. And what we actually did, what the actual focus of it was related to something that happened in a neighboring state. It was a very unfortunate event. I think anybody that's involved in construction has either had it experience on one of their sites or they never experienced it on one of their sites. There was a fatality in Baltimore on I-95, and it was a very bad fatality. It was, there's been National Transportation Safety Board reports on it. The contractor did nothing wrong, but we looked at it as, and specifically my supervisor looked at it as an opportunity to harness some of what we were doing to improve work zone safety. Now, at the time when this occurred, we were deeply involved in Everyday Count 6 e-ticketing initiative. And if you look at those e-ticketing initiatives, a lot of those tickets, most of those tickets, have location-based data associated with them. And the thought was, can we take that location-based data and use it to improve work zone safety, to put a notification out? Because if you look at our current process at the time, it was very manual. So the hope was we can use this digital information to make an automated notification. And the discussion at the time with our vendor was, yeah, we can probably do that. We can make it automated. We can remove multiple manual inputs and turn it into something that's hands-off. So inspectors don't have to deal with it every single day. So our traffic management folks don't have to deal with it every day, but a notice still goes out to the traveling public. But we were just dealing with e-ticketing data, and that wasn't quite enough to give updates throughout the life of a project. We're not always receiving hot mix. We're not always receiving stone. We're not always receiving concrete. We needed additional data sources. And what we ended up doing is we ended up going and capturing equipment-based data sources. And that equipment is active. Doesn't matter if you're receiving material. If you're digging a hole, you need to have active equipment on that site. And with telematics, we can capture that status and update the traveling public as to what we're doing. But as we went through this process, we also discovered another issue. And the issue is that Delaware can't have 2, 3, 4, 5 connections to Caterpillar and Iowa and all these other states. We can't all be trying to do the same thing because that becomes a burden for everyone to manage. We needed to simplify that connection. So it's one connection per OEM, not 50. So it's one connection per DOT, not 7, 8, 9, 10. So that was the focus. That was what we really zeroed in on, is building this connection, this pipeline of data, so it could easily flow into the state from the OEMs. And it required cooperation between owners, contractors, and OEMs all working together. And it's easy to get people working together when you have safety as that goal. because safety is not just a goal, it's a responsibility. But there's, of course, an issue with that. Everybody's willing to share some data to make a site safer, but they don't want to share all the data. So part of the beauty of having a portal is that not only do agencies only have to maintain one connection, not only do OEMs only have to maintain one connection, but we only see the relevant data, only the important data to us. Contractors don't need to share where their equipment is all the time. They just need to share it when it's within our work zone. So we're not getting that extraneous information. And with all this, we were able to put together a work zone monitor. And here we can easily see job site status, how we're getting that status, whether it's from e-ticketing data or from equipment telematics, and whether or not we're transmitting that status out to the traveling public in their navigation applications. Now, the way we did this, the way we're able to get the equipment information was based upon work that the OEMs had already done, an existing ISO specification. So we built off the back of that. And that was a great starting point to get the status of that equipment within a work zone to be able to notify the public. But as it turns out, all these awesome OEMs have a lot of other information that they could give us. And you can see here, this was what DelDOT specification was asking for as optional stuff. Just try and share what you can. But there's an issue with that in that if Delaware starts asking for the depth of the miller and Florida's asking for the cross slope of the miller, and I was asking for something completely different, like say the temperature on the back of the screed of the paver. All these different states doing different things creates an issue in that OEMs don't know what to focus on. Contractors don't know necessarily what to buy, especially multi-state contractors. And state DOTs, if they're going their own direction, aren't building momentum, aren't expanding their data set. So that's really what the key to this pooled fund is. We're trying to all come together, figure out what our common priorities are. So state DOTs can specify something jointly. So OEMs can go ahead and all agree, hey, we're going to work on sensors that do this, and the units for those sensors are going to be this. And so contractors can plan to purchase equipment in advance so they're not left buying one sensor for one state and another sensor for another state. We're trying to all come together to prioritize, not saying one thing's more important than the other as far as ignore it, just saying, here's what we think we can do first. Here's where the momentum is, and we build off that momentum. The key to our ADCMS program was going after the lowest hanging fruit, and that's what this is. So where does that fit into our national priorities? As we all know, Everyday Counts 8 is out, and everything we're doing with this pooled fund, expanding on the ADCMS program, connects very nicely into it. Connected corridors, integrated project delivery. We built a data pipeline, and we want to expand that data pipeline to try and make our sites safer, make our inspectors more efficient, and make our product better. So that's where we're at. That's why we need this pooled fund. And I think there's a lot of interesting ways we can go with it. Our other states are going to talk about that. And I think it's fitting that I'm going to pass this off to Maryland, who in some way was kind of the start of all this, at least the start of the idea. Thank you.
Thank you so much, Cassidy. If you want to unshare your screen, and Jim, you share your screen with your slides.
And there we go.
All right. So, thank you for joining us today. I'm Jimmy Hobatter, the E-Construction Business Manager with the Maryland Department of Transportation State Highway Administration. While I'm representing our program today, I want to emphasize that the work I do is driven by an incredible multidisciplinary team dedicated to meeting the evolving digital needs of modern highway construction. Today, I'm excited to share how Maryland is leveraging connected construction data to transform field activity into real-time safety signals to protect our workers and build a lasting digital ecosystem. Early in my career as an inspector, I remember two things that really left a lasting, vivid impression on me. The first was on a bridge deck with phase construction. So the half I'm on is the work zone and traffic's on the other currently disconnected side. I remember watching traffic go by in the open lane and seeing the deck bounce vertically almost my entire height, which isn't that much, which is good because flexibility is engineered into bridges, but it feels crazy to witness in person. The other memory I have that will never leave me was during a night paving operation on a 2-lane, 55-mile-per-hour road. And I'll start my story by saying that I've been blessed in my career to never have been on a job with a fatality. But aerodynamics do this remarkable thing when you're standing next to a live lane of traffic. When a vehicle first approaches, a high pressure bow wave pushes you back away from traffic. But as it speeds past, it creates a sudden, strong, low pressure vacuum behind it that pulls you right toward the live lane, just after you've already been thrown off balance from the approach. And that's just a vehicle passing normally without any other incidents or accidents. So just looking at 12 miles over the posted 55-mile-per-hour speed limit in this example, which is the starting point for our automated speed enforcement in Maryland, my cool aerodynamic effect can exert up to 40 pounds of force, depending on how close they pass to the vehicle and how big the vehicle is. That speed also increases the stopping distance of the vehicle by up to 36%. Now consider speeding through a long 2-mile work zone at a full-on clip of 80 miles per hour as opposed to the posted 55. That person's only saving 40 seconds on their trip. So in 2024, Maryland updated their laws about automated speed enforcement after a devastating accident on the Baltimore Beltway in 2023 that Cassidy'd already mentioned. The Maryland Road Workers Protection Act updated our automated speed enforcement laws, which is the little car with the lights that flash at you when you zip past at the beginning of a road work that mails you a ticket about a week or so later. Anyone traveling 12 miles or more over the posted speed limit is issued a speeding ticket in increasing increments at the different speeding thresholds. The faster you go, the more it hurts. The rub is that those fines are doubled when there are workers present when your car goes buzzing past. This is one of those laws that is designed to hurt people's wallets in order to make them not want to do the dangerous thing. This is not trying to shake them down for money. The control is completely in the hands of the passing vehicle to just slow down and keep everyone safe. The real crux of any good law is enforcement, though. How can we definitively prove each time that the workers were on site and limit the error for manual reporting? Right now, someone has to physically flip a switch that says, hey, we're here, and then remember to turn it off whenever they're wrapping up. The answer is actually fairly simple. We can automate information gathering by utilizing real-time ticket deliveries and telematic information provided by equipment within the work zone. We can paint a solid picture of exactly when people were on the job site and doing construction activities. We can take that data and use it for immediate updates to GPS programs used by the travelers, so they know 1 to 2 miles ahead of time that workers are present. And if they still make the decision to jeopardize safety, we'll have that log of activity and make sure the fine hits home and hopefully teach a valuable lesson to slow down in the future. Now, this also works with the projects that don't have automated speed enforcement cameras as well, because all the data stream is still pinging the work zones data based on delivery and equipment, and is then able to notify the public GPS programs. They don't have the same risk of getting a ticket they would with one of the automated speed enforcement projects, but hey, workers are still present, so slow down anyway. It's worth noting that speed enforcement effects are working in Maryland. Work zone fatalities have decreased since the Beltway accident and the implementation of these automated speed enforcement laws. Fatalities have dropped to their lowest number in a decade, with, I believe, 9 in 2025 and 4 so far in 2026. Now, to be clear here, even 1 is far too many. There are no acceptable casualties in a completely avoidable circumstance. Safety is going to be a top priority, but that wealth of data has far-reaching applications. Once you capture real-time, high-fidelity digital construction data, its value extends far beyond a single project or document. We are actively breaking down departmental silos to push this field data into an enterprise-wide asset. Reaching out into different divisions, we can use the data-driven infrastructure to our advantage. We can create an overall quality control with the data that isn't possible with previous tracking methods. By defining the digital work zones, we're able to take data collection and present a more vivid picture. ArcGIS overlays can show material placement along with paver and roller passes. If we add in inspection work photos tagged with GPS data and recognition, along with drone overlays, time-lapsed increments, we're able to see exactly how job site came together, almost a complete as-built model. We can use this information to effectively direct maintenance assets from the ArcGIS layers because we can put together and identify possible reasons for failures and issues that arise along with construction crews long after they've moved on. This information can then be used to troubleshoot issues and help implement better situational solutions and plans, better specifications based on real data, and targeted inspector training with explicit examples. To bring this full circle, digital data is not just administrative record keeping, it's modern safety infrastructure. The ecosystem here requires involvement though, more relevant data and with more divisions utilizing adding. We have to build that data structure out, which requires all our stakeholders coming together, from design through inspection and our contractors. We have the data stream to create that safety infrastructure, but it only works when all the players come to the table and help each other. We want to see more ideas, taking the data further, exploring new ways of capturing information and applying it to the aggregated model. The goal is to create a broader return of investment, getting out of the data more than what we put in. We need real-time accurate information in a wide variety of sources. The data is the real power here that will drive safety forward, and we can never have too much. Thank you.
Thank you so much,
Allie?
Jimmy. If you would stop sharing screen so that Cedric with Iowa DOT can share his.
All right. If I can get a thumbs up, you can see my presentation. Excellent. So I get the joy of kind of showing you guys what it's all about and what we've done in Iowa, how the system works. So just continue here. So, all right. So, a lot of people hear e-ticketing and we're talking about connected equipment, and I like to just say it's way more than e-ticketing. We started with an e-ticketing platform, but it's way more than that. It's safety, right? That's our number one goal here is the ability to take our inspectors and our construction, partners, contractors away from the dangerous pinch points and things like that. And so, we're digitizing our concrete, our asphalt tickets, we're project documentation, all those things you can see here. We've taken over 2,000 photos just a little over a year and a half using this system. So great project documentation. We're connected to Ashore Project. We're connected to drone software. And so in the piece here, we're talking about is the connected equipment itself. And we have a little over 1,300 pieces of equipment connected here in Iowa. And so that really shows the mass of the equipment we're connecting to. And I'll talk about it a little bit later here, but we're from the asphalt paver to the milling machine down to the side by side that the contractor has. So if that side by side is out there doing, minimal work that day with anybody else, we know that work zone's active. So, it's not just the asphalt pavers or the concrete pavers. It's everything. Every type of equipment that has GPS on it anymore, we can connect to. And so the work zone awareness, feeding into the work zone data exchange feed is big for us as well. Getting all of our traffic management centers connected together so we can see all of the data. And then digital stationing and, Jimmy just talked about the as-built creation. Once we get all the data, we're going to have a great as-built of what we built. And so just a little snip of what we do, what we've done here in Iowa and the I'll say a big variety of what we do. I mean, we got over 620 users that have access to our system, 200 plus inspectors that are in it. You can see here in 2025, we had enough to pave 125 miles of ready mix concrete, 352 miles of asphalt. So it's a large volume of tickets coming into the system that we know and can make out these work zone, connections, these safety feeds for everybody. And so what is it? What's connected? And so Cassidy had already hit on this as well, and Jimmy both. But we're taking the OEMs, right? So we're not asking the contractors really to do anything more than, hey, you have a connection to any one of those large vendors that we have out there, right? And so John Deere, Cat, Komatsu, you name it, we're connecting to those, and we're using a standard connection. So Cassidy hit on that as well. So um, and when I talk to the contractors here in the state of Iowa about using this system and what is it about, it's about safety. It's a safety for their people as well, right? And saying that when your equipment is on our job site, we know where the job site's at. Once that equipment is turned on, we're giving out a safety feed to everybody. So that only is not helping our own inspectors, it's helping the contractor staff. And that's been a great relationship I've had with our contractors here in Iowa, is just telling that story of the safety that, we're out here to look after everybody, not just DOT or whatever. It's everybody involved in the system. So, and really the message is pretty simple. Hey, workers present. And I got a slide here that'll show you that where the impact comes from that. But down the bottom here, this is a report. We're with Waze and Google Maps, and this is old for 2025. We have almost tripled that now on notifications to people, but you can see the impact. 6 million people are impacted. That's a very large number of people just in the small sample size that we have today. And once we get it rolled out to more and more, I can't imagine that number is going to be. So, everybody that drives through that job site. And Cassidy kind of showed this as well. The what it is. Here it is. Here's what's connected. Is it the ready mix ticket? Is it the asphalt ticket? Is it the equipment? It's all three, right? And so if any one of those is tagged on, we can send out the work zone awareness as well. So automatically broadcasting that's key too. Is like, contractor, you don't have to do anything, right? You don't have to touch anything. Inspector, we just set up the work zone. And that's it. And we're done. We set up at the beginning of the project and we're done. And I think that's key for me, is we've got enough work to do. We don't need to add to it. And so having that, I call it auto magic work in the background is really beneficial for all of us. And you can see here how many work zones we've created in the last year. And in we went from 17 all the way up to, we have 80 across the state now. Now that's not every single work zone we have, anything like that, but you can see the impact is growing and growing even more. And there's the machine count that I was talking about, over 1,300 pieces of equipment connected. So that's a real life, and you can see it's spread across the state of Iowa. It's not just in one centralized location. It's across the entire state, which is key. And so what does it look like? And so here's an example that we have of, on the left-hand side in our application, we can see where that equipment's at. And if it's yellow, it's turned on and it works great, right? On the right-hand side, what I love to show is, if you notice the 548 with the thumbs up. And what I say is, if you've ever been Google Maps or Waze and it tells you, hey, is this work zone still here, blah, 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 all those things. That's how many people are actually connecting to this. Our own message from the DOT saying, hey, there's a work zone here for the next 2 months, 3 months, had 2 likes. This in one day, if I've had 548 likes. And I like to, say that because it says active construction workers present is the key word there, right? If people see that before they get to the work zone, that's key, is that they see that before they get to the work zone. Oh, there's people here. I'll slow down. People care about people, right? And so when people see work zones, they automatically think, I got to get through this thing as fast as I can. But if they see workers present here, I think they take a real sense in knowing, you know what, I should probably slow down. What's going on? So that we're actually having a good flow of traffic through our work zones. And this is exactly what we're doing. You can see that we've got the shuttle buggy there in front of the asphalt paver. We have all the rollers. We have actually the blade back there that's taking care of the rock on the shoulders. So you can see we have all the different types of equipment. It's not just, again, the pavers or the big equipment. It's everything out there. And so on the right-hand side, this is kind of our monitoring what we can see and where we can see. And I think it's key. The other thing that I talk to the contractors about is when it's off this job site, I have no idea where your equipment's at, nor do I care. I only care when it's on our job site. And so for contractors that are thinking about this or looking into this, that's the biggest thing I think they worry about. Like, you don't need to know where all my equipment's at. You're right. I don't care where your equipment's at. I only care when it's on and in our work zone itself. And so that's kind of an image of this. And then one of the last slides here, a couple slides here, is notice this paver is gray. And so I happened to be on site this day, and the contractor broke down right there at that location. And so for asset management, asset tracking, they actually blew a hose in their antifreeze. And so we had antifreeze running all over. And so we had to, stop paving for that day, cut it out. Well, now we know where exactly that happened at on the project site. So that's another good thing. So we can monitor this area for future replacement if need be, or whatever. But that's another big piece to this. And so yep, it was a good example. I left early, so I didn't know what all happened. So that was, but there is that's what the realization of how this equipment can help the DOTs out as well. And then so just another quite view. This is a bigger job, on Interstate 80 through Iowa, big corridor. And we had several pieces of equipment connected here. And you can see all the equipment that's turned on across this project site. And that's just, again, putting out that message that there's workers present here. And you can see all the different types of equipment we have. We have dozers, excavators, you name it. We had it connected. So. And then just a little bit of this ties everything in together, worth the work zones, the drone imagery, the e-tickets, the connected equipment. It's all in one location, which is key for us, is that, having one app instead of 25 apps really helps us. And that ties the connected equipment into all this. So that's it for me. Thank you very much.
That was amazing, Cedric.
Share.
If you can stop sharing your screen, and then we'll invite Dr. Sturgill to share his screen.
Okay, where's my stop? That's not what you wanted.
If you mouse to the top of your screen, you should see a red button that says stop sharing.
Yeah, that's what I'm not seeing.
Let me try
Sorry,
to
guys.
just
Hang
take
with
it
me.
over. Let me see if that just
Can
take
you
it
take
over.
it over?
What did I do?
Perfect.
Thank you, Roy.
Yeah,
Thank you,
no
Roy.
problem.
Thank you, Cedric.
Yes.
Well, good afternoon and good morning. I have the pleasure of following those great presentations to talk about, what they showed were examples of how they're using connected equipment, and what I want to talk about is how this moves forward in the future. And certainly one of the examples that got brought up are, some of the negative circumstances by which we change our paradigm into new ventures, such as e-ticketing, or trying to do the safety feeds based on, accidents in the work zones. And if we think even about this meeting today, how many meetings do we have now that are virtual, and how, we were kind of through the pandemic pushed into virtual settings more often than we previously had been. And so really, how far away are we from visiting job sites like this, being able to be there virtually and see them and see what we need to look at? I mean, these things happen today. We were experimenting with doing these things even with mobile devices when we started having more connectivity through those to look at things on sites. So what I want to start with is talk about the state of the practice in construction inspection and management. And we've been using the same sensors, if you will, for thousands of years. So if we think about, typically we've got inspectors on site that are using their senses to verify, to give us quality assurance. And, you may say, well, is taste really a sense that gets used to verify things? You haven't lived until you've been in a geology lab and licked a rock to see if it was salt. So we do use these senses. And how can we continue to do the verification that we need to do and rely on those senses? Well, it's difficult. And one of the unfortunate and inconvenient truths that we're having to deal with DOTs is that staffing levels no longer allow for the quality assurance and verification that we would like. And so I've got a chart here, and this is an anonymous timeline, an anonymous state, but it shows a trend that exists with many DOTs across the US. The trend is showing that fewer and fewer DOT employees are able to be out on site, and our construction spending is at a relatively at least stable, if not a bit of an uptick. So we're doing more work with fewer people. I think we've heard that consistently across DOTs. And so how do we continue to provide the levels of verification and assurance in the construction products that we're getting out there in the field? When we don't have enough sensors of our own, what do we resort to? Some states have resorted to using construction or consultant engineering and inspection. Sometimes we have resulted to using technologies. But with technologies, we have issues that come up. How do we deal with the data flows from the technology? What level of trust do we have in the data that we are getting from that technology? And so those are problems that we continue to have to work through. And connected equipment is an avenue that we can use with some other duplicative technologies to reach a comfort level. And we've already heard about some of the use cases in the previous 3 presentations, but I have a few others that I'm just going to reiterate that we can use construction inspection technology and visualization techniques in many ways. So we can use the technology to build efficiency for our current staff, to help them be more efficient, to have more coverage. We can use the technology for automated data flows. So that's an example of where e-ticketing provides us with the automated feed of the ticketing data. We can use different visualization platforms, modeling. We can use the technology for as-built development, and then we can use the technology for remote virtual inspection. And this is a kind of an advancing topic in our area, again, to supplement the fact that we are doing more with less, and we have less inspection staff available to do that assurance and verification that we need. So I've got some examples here. One example, again, for going back to how we use the technology. So an example of efficiency, this was a study that we did where we used a handheld device and photogrammetry. You can also use the LiDAR features of an iPhone or an iPad to where sometimes that's referred to as pocket LiDAR, where we used a device, we used the RTK correction GNSS antenna with that device. We were able to go out and capture bridge deck patching so that we could perform measurements in the office. And with a quick walk across the bridge deck and capturing that data, we had everything we needed to go in and do those measurements later. Whereas prior approach would have included an inspector or surveyor to go around to each one of those points, and at each let's say angle or corner of those patches, take a individual GPS shot, which would have taken us substantially more time. So the technology was helping us to be more efficient. There's also data flows from various sources, and one of which can be this connected equipment concept. With the connected equipment, there's a range of different sensors and telematic data that we can collect. It can be data from add-on sensors that I'll talk about in a moment. It can be the data from the telematics themselves. And we can do a range of different data collection for different purposes that help support our inspection needs. So whether that's getting temperatures, whether that's understanding speeds, whether that's understanding the layer thicknesses to be able to do theoretical tonnages. Those are all things that we can do from this data that we're getting from the equipment. Again, there's add-on sensors. So this is an example that you may have seen where you have a paver-mounted thermal profiler. This infrared camera is giving you highly accurate temperatures across the full mat of the pavement. Whereas historically we may have gone out there with kind of spot our sensors to get individual readings at different locations on the mat. And then this could create a data flow that we have this for long term, and we can see temperature variations and speed of paver. And so an example that we had that we've done a study for, this is showing that, with a material transfer vehicle, you get really good temperature consistency across the mat. We have that data, we have the paver speed and all that. And then that becomes a record that we can use as part of, as-builting and asset management. And in as-builting and as-built development, this is another thing that can be simplified by technologies that we have. So using a similar, actually the same technology that we use for the bridge deck patch measurements, you can create full models of the assets that you have, such as this pipe, collected in minutes, instead of trying to take individual GPS points along that pipe that could take hours. So again, being efficient, being automated, and these are all individual technologies that exist today, that get used today. And so when you start to think about coupling up these technologies, so when the technologies collaborate, we can piece together oversight for an entire project. So DOTs today, whether some may be experiencing this, some may have more fortunate staffing than other DOTs, but the fact is there's some resurfacing projects that no longer have the oversight, or at least don't have the oversight they used to. When I was working early on, we would have even multiple people working on a resurfacing project. Now, my understanding is there's maybe multiple resurfacing projects handled by one particular inspector. But we have technology that we can use to do the same things that an inspector is doing on site. So we can use e-ticketing that can help us get the ticket information and even do theoretical tonnage calculations. We can use that paver-mounted thermal profiler to get the temperature readings, or individual temperature sensors that are getting readings in the hopper and other locations. We could use intelligent compaction rollers, or rollers that are just outfitted with GPS units, in order to understand what the roller coverage is and the roller operation, and basically get all the data that we want through inspection, maybe even more accurately and more efficiently than using inspectors themselves. So this concept of collaborating technology takes us to what the future may hold with connected equipment. So as we think about connected equipment, connected construction, we can think about inspectors themselves having sensors and technologies that they're using in the field. We can think about field deployed sensors, such as pole mounted cameras, UAS systems, those type of things. We can think about the equipment mounted sensors, so the add-on sensors, and then we can think about the equipment telematics and the system-based sensors that are included in the equipment themselves. And we need to be having a communication with the manufacturers about what those need to be. That's one of the points that Cassidy mentioned. And this is to make sure the manufacturers hear a unified voice of what the DOTs want. And that comes back to the objective of the pooled fund study, because there is a future with connected equipment as to what inspection and verification might look like. And that future starts here, and that future needs data. And so this is an example of what future might hold, where our inspection forces, our engineering forces, may be located in a command center, looking out over various different projects. The equipment may be supplemented. The data equipment may be supplemented by drones and other sensors that are deployed in the field. Maybe having one inspector checking out multiple jobs, and all that data feeds in with automated alerts when things need to be checked out in more detail, as-builting that's occurring automatically and being stored for future analysis. And this is a future that is, while futuristic, is a reality. We have the technologies today. We just have to start piecing them together, and that's part of what this pooled fund study is about. So how can you participate? This is a QR code to take you to that pooled fund advertisement. As mentioned, there's a 100% match waiver. You can use your SPNR funds, and I'll mention what those are in just a minute. We're looking for a 5-year commitment with a recommended annual commitment of 20,000. And so you may be asking, like, where does this money come from? I don't have it in my budget. So SBR is one source that could be used to help support this commitment. SPNR funds are state planning and research funds provided by FHWA to DOTs. They're administered through the Code of Federal Regulations. And typically there's a 2% set aside that the DOTs set out as part of these funds for planning and research purposes. Those are divided into 2 parts. One is for planning studies, part A. Part B would be the research development technology part. And so the part B is the research program that can be used for research, looking at new technologies, improvements in processes through various project set phases, supporting technology transfer, and partnering with universities, transportation centers, consultants for research, but also for participation in pooled fund studies. So the SPR Part B is a source that could be used, and those funds get allocated based on the DOT identifying what their needs are, what their research gaps are, where they want to use that money. And so typically the selection goes through technical committees, but the research leadership is really who aligns the projects with the DOT's strategic goals. So if you want to identify if the SPR Part B is a source of funds that you could use to participate, contact your research office. Your research office can help you navigate how to use SPNR money to participate. But if SPNR is not the only funds to use to support your efforts, as already mentioned, the pooled fund here would align well with the EDC 8 Connected Corridors Initiative and other initiatives as part of EDC. So there's a QR code to the EDC program and then a QR code to the EDC Connected Corridors. But there's other funding opportunities, and that's the third QR code, such as using the STIC incentive funds, aid demonstration funds, AMR. You could potentially get increased federal cost share to participate, CMAQ funds, and others. So there's funding available. It doesn't necessarily have to come from your direct budget. So again, just to kind of close up here, the importance of this pooled fund is to get us to have a collective voice as DOTs, to really work with the manufacturers so that this connected equipment concept can come in and support our future in inspection, verification, increased safety, all the things that have been mentioned today, with a minimal individual financial commitment. So instead of each state, looking at this separately, we look at it together with a unified voice. So with that, I'll hand it back over to Allie.
That was amazing, Roy. And I want to say first, thank you to all of our presenters and ask each of you to come back on video and come off mute because we do have some questions that have been collected in the Q&A section of Zoom. Those of you who are still attending the webinar and have questions, please load additional questions in the Q&A button, which is on the bottom of your Zoom screen. And I want to start with question number 1, which is to Cedric. Cedric, as you progress through connected equipment, are you going to continue to use a proprietary work zone safety system, or do you have any plans at Iowa DOT to develop an open source option? And Cedric, once you answer to that question, I'm going to actually ask Cassidy and Jimmy to respond as well. But let's start with Cedric. Any plans to develop an open source option?
Yeah, I think I don't know exactly what they're trying to get at, but I mean, we are kind of open source in that, the OEMs are, anybody can go get that data really. So it's not locked down to just this proprietary, EDOT, for example. We're always looking at what's out there, what's new, what's efficient. So, there's always opportunities for all of us. So, Cassidy, you probably have the best knowledge with any of this stuff anyway. So I'll kick it off to Cassidy.
I appreciate that. Honestly, my answer is not going to be much different than yours. we'll always, as a DOT, we'll always look at options. And I think the thing I'd like to point to here is the entire point of this venture is not necessarily work zone safety. Yes, that's what started it. Yes, I think everybody should be using it for that purpose. But the point of this venture is to get the DOTs together with the equipment OEMs to decide what direction we want to go for the next piece of data we want to capture. For DelDOT, it's certainly going to be going into EDOT for the foreseeable future. It's a great way to filter stuff, so we only see what's relevant. But that doesn't preclude somebody who's not in Haul Hub or EDOT from participating in this pooled fund. I think there's still great benefit of all the states getting together and looking at this cooperatively with the OEMs to try and develop additional data sets that both contractors and state DOTs can use together to make our work better.
Yeah, agreed. And I'll say that, my presentation, I should have said this in the beginning, is this is what we're using. I'm not promoting any one vendor or anything like that, right? It's what we're currently using. So
Jimmy, anything to add to the responses to this question
I,
about
I
open
agree.
source?
I agree completely with what they said. It's difficult to try and get the information from like different areas. There's only so many people in the game right now that are able to collect this information for us. But I mean, as far as getting it out there more, we're looking at ArcGIS options, like trying to get it into tiles within the job sites so that we could share that information more readily. But as far as collecting it, it's kind of hard to get it from different areas.
Thank you all. We have another question. I love this question, and I think that everyone has touched on the information that we're giving to motorists. And the question is, how much is too much information to give to the motorists? Wouldn't one message suffice showing the work zone is active? Where is the quote unquote active construction message displayed? So how are we managing the narrative to the traveling public, whether it's through dynamic message boards, apps, navigation apps like Waze and Google, or even V2X and other connected and autonomous vehicle platforms. Cassidy, you go first.
So I love this question because it is something that is on our mind constantly. It was one of the first things we discussed. It turns out mapping companies don't necessarily like DOT data because we're not very clean in what we say. So when we started off with our ADCMS program, we focused on a very generic message, which is, in Delaware, it was workers present, slow down. That was our focus. And I think the other states are doing basically a very similar message, if not the exact same message. So we're focusing on a very generic message at this time with the plans to go ahead and become more precise. But accuracy is the key to what we communicate to the traveling public. That's how we're going to get action out of them. That's also how we're going to get other consumer mapping applications start taking that data and using it, whether it be, Waze still or Google Maps or Apple Maps or some of the other companies like Here Technologies. We have to be precise in what we say. So that's the focus.
yeah, I'll say that I have a meeting in 6 minutes on this very topic. Believe it or not, we call it our work zone data, analyzer, and so we're looking at all the things that we collect, not just connected equipment or anything else. Like, how can we take even what people are reporting, from Google Maps? Because if you look at a work zone anymore, we got a work zone in Iowa. There must be 50 different notifications, and that's from others. That's not from the DOT even notifying that there's a work zone here and all that. So we want to try to figure out, okay, we're giving out a message to DOT. We have this work zone present. There's other things out there. We have our message boards. We have our lane, our arrows showing up on these things. And so how can we take all that data and give out one precise message to the public and not 50? And some of them aren't even from us, like I said. So some of them come from other vendors, other applications. So we want to be able to bring everything into one data pie, basically.
And let me volley a second question of the same nature back to you. This involves alerts and notifications. Are your state DOTs working on giving workers alerts when there is a vehicle approaching at a high and dangerous speed as they're approaching the work zone?
Yeah, we have in Iowa. We've tested a couple different products out there of, like they're set up on a cone, and then if somebody breaks that barrier of a cone, you've got like a little thing on your vest that warns you. We've got other sensors that show up on like a paver, that goes off, flashes if there's somebody that encroaches into. So we are always constantly looking into those type of things, from the hardware to the software to everything in between. So,
And now I'll piggyback off of that statement. And those are great technologies to have, but we also have to keep in mind that it's not necessarily related to telematics enabled equipment. The biggest issue you have when you start talking telematics is latency. When you have a vehicle traveling down the road at 65 miles an hour, ideally, that latency can make a massive difference. So it's not necessarily going to be telematics enabled alerts to workers in the job site, that may be in harm's way. It might be notification to, the MOT person that they need to go check the pattern or something like that. But I think any sort of work zone intrusion needs to be localized to the actual site.
Awesome. Hey, Roy, I've got a technical lightning round question for you. I need you to answer in 1 minute, but there's a question about the pocket LiDAR use and whether or not the data from pocket LiDAR doesn't meet the same standards as traditional means of measuring with wheel or tape, and how you approach the pocket LiDAR data, and whether or not it's a violation of survey protected practice.
Yeah, so I'll try to be as quick as possible. I think this question comes from some states are dealing with situations where kind of their survey groups are coming forward and saying, "Hey, you're using these tools that are highly accurate, and this is infringing on our professional practice." It depends on the state. State law varies. That either says engineering survey or more land boundary survey as being protected. Like in Iowa, we can still do engineering survey. And so that's one caveat depending on the state. The other thing is from a DOT's perspective, I mean, you're really using those tools to measure things that are being built in your space. And so using a tool is not proclaiming yourself as a surveyor or anything to that regard. You're strictly, as the question mentioned, using what tools you have at hand, whether it's a wheel, whether it's photogrammetry, whether it's your phone, whatever it is. So it is a tricky practice. It is a tricky question right now because you do have some bodies of surveyors that are kind of trying to carve out and protect their field.
Let me note for our attendees that a video, a recording of this webinar and the slide decks are going to be distributed to attendees of the webinar, and they're going to be distributed publicly after this webinar. Last question before we lose Cedric and our other presenters. We have an attendee who wants to join the pooled fund, and is interested in your best tips on how to approach leadership with a value proposition and a compelling argument to get their state DOT enrolled and signed up for the Connected Construction Data Alliance. Cedric, let's start with you.
Sure. This is always the thing is, hey, can I have money? That's always the hardest part about going to leadership, because there's a lot of initiatives out there going. There's a lot of interest in, number one in Iowa is safety right now, right? We care about safety the most. So anything that I can bring to the table and I say, here's a real impact, right? If I can save one serious crash or even one fatality, that's a large dollar amount that we're saving in the background from, well, obviously people's lives, just how do I say, our cost of dealing with stuff like this. So it really isn't a hard push from my side, honestly, because our goal is safety, and it relates into our mission as the DOT itself.
Let me ask Cassidy and Jimmy for any of their best tips on promoting the Transportation Pooled Fund with leadership in a state DOT.
So if safety doesn't do it, I would say go after asset management because that's what we're really working towards, right? If you're collecting the information off the equipment itself, you are allowing your inspectors to focus on making sure the work is done properly rather than calculating how much work has been done. I think that's the real key. These are tools to give us a better, give the traveling public really a better product at the end of the day, and not just get you the better product, but also record it long term in your asset management system. You're not having to go back after the fact and recollect things. It's already on the equipment. If the equipment tells you you paved, 3 miles, do you really need to question it that much? Like that's the direction we're going. We're certainly not there yet, but that's the direction we're going. So I think asset management, you want to be in the room to discuss what the most important thing is for your DOT to make sure we are selecting the sensors that make sense for all of us.
Jimmy, anything to add?
No, they pretty much pegged it. It's all about value versus cost. So, I mean, if you value the safety, you're going to look for the things that are going to be the most cost effective for that end. And like Cedric and Cassidy said, these things are really pushing that safety goal out there.
I want to thank everyone for participating, both our attendees and our presenters from Maryland, Delaware, and Iowa DOT. This has been an absolute pleasure to host this webinar. You can see the landing page for the Transportation Pooled Fund that establishes the Connected Construction Data Alliance. You'll be receiving a recording of the webinar and the slides in the next day or two. But in the meantime, please reach out with questions. You can see Cassidy's email is on the screen. And we will be continuing to distribute information about the Transportation Pooled Fund as it comes together. So thanks so much and enjoy the rest of your day.